For this problem, we need to fill the information in and graph. So notice that this time the blanks, we only have 2 blanks for the zeros. That's because you're only going to have 2 zeros on this problem. The 2 that's out front, we can't set that equal to 0. So that's not going to give you one of the zeros that's on here. You can only get a 0 if there's an X involved. So to fill in these zeros, you're just going to take each piece individually and set it equal to 0. So I'm going to show this one here, x minus 3 squared equals 0. Now, if I take the square root of both sides, I'm going to get x minus 3 equals plus or minus square root of 0, which is just going to be 0. And we can add 3 to both sides and get x is equal to 3. So for this first piece, we're going to get a 3. The second piece, so really all that's happening here is you're just going to get the opposite sign of whatever you see inside here. 3 minus 3 would give you a 0. Now we have to think about, well, what would give us a 0 here? It's the opposite of 4. And so that's going to be negative 4. So negative 4 is going to be the 0 for that one. Now the multiplicity would be the powers that are attached to each of the factored pieces here. The multiplicity would be 2 in each case. So whether it crosses or touches determines whether the multiplicity that's determined by whether the multiplicity is even or odd. So if it's an even multiplicity, it's going to touch like we have here. If it was an odd multiplicity, it would cross. So in this case, it would touch at both of these zeros. Now the degree you can get by adding up the multiplicities. So if you add the multiplicities, that's going to give you the degree. So if I add those together, 2 plus 2 is going to be 4. The max number of turning points is always going to be 1 less than your degree. So that's going to be 3. The y-intercept, we're going to do that down here. Y-intercept is when you put in a 0 for the x. So I'm going to put a 0 in for each of these. So 2 times I have 0 minus 3 squared and 0 plus 4 squared. So this one is going to be 2 times 9 and then times 16. So by doing all that, that's going to give you 288 as the 0. So we'll put that down here for 288. So I'll put 0 and 288 because now it's a coordinate. And that'll be actually one of the coordinates on our graph that we'll do in a little bit here. Now I want to do the graph behaves like blank for large values of absolute value of x. Now, yes, you could multiply all this out if you wanted to, but that's not necessary to do. Whatever the degree is, we know that we're going to have something, an x raised to the 4th power we're going to have, because that's the degree that's going to end up being the highest power that you see on this particular problem. Then the number that comes in front of here is just going to be whatever coefficients that you see. So there's a 2 that's here. That means that there'll be a 2 in front of there. All these other ones are 1s. So if I were able to multiply, if I multiply these out, I would just get x squared plus some other things. This would be x squared plus some other things, which means that I'm just going to end up with a 2 as the coefficient. So this is what you would do. This is what the graph resembles for large values, 2x to the 4th. Now that is going to actually help us for end behavior. Okay, so in the notes, we went over some different end behavior models that has to do with the degree and whether the number in front of the x with the highest power is positive or negative. Now for this case, n is even because that's what I have right here. The degree is 4. That's your degree is n. N is even. And then the a of n, that's just the coefficient. So we're just going to look at this term here. And we see here that a sub n is greater than 0 is what we have. That means if we look at our behavior models, it's going to look like this here. So I'm going to have something going up and something going up for each of those. There might be some other things happening in between, but I know for sure it's going to go up and it's going to go up like that. And that's my end behavior. That's going to give me an idea of how to make this sketch here. So first of all, I know it crosses at +3. It crosses at -4. Now I'm not going to use a scale for the y-axis. I'm just going to put a dot all the way up here, and we're going to say that this is 0 and 288. So I know it's going to have to go all the way up through that point. So now let's fill in what the graph looks like. We have an arrow coming down, which means that it's going to come down from the top. It's going to come down to here. And it says it touches, which means that I know it's going to do a little bounce like that. It's going to come down and go like that. Also, because this is a square here, that's another hint. That's going to tell us that this graph kind of resembles a parabola at that point where it crosses. So a couple of different ways we can determine that. But whenever it touches, you'll see it doing that kind of bounce. It resembles a parabola in shape. Okay, now it's going to go all the way up to here, and it's going to go through this point, and then it's going to have to come back down again to touch this one. So let me draw that a little bit better here. It's going to go through this, and once again it touches, so it's going to come out like that. So this is going to be a big W shape is what the graph is going to look like. So again, it does another bounce here because we say that it touches at that point. So it resembles, again, a big W shape, and that would be your overall graph.